Welcome to all. Today I am going to discuss principle of conservation of mechanical energy. Principle of conservation of mechanical energy states that the total mechanical energy in a system, that is sum of potential and kinetic energies, remains constant as long as the only forces acting are conservative forces. Now see the derivation of conservation of mechanical energy. Conservation of mechanical energy. Consider a body of mass m is lying at a height h from the ground. As this body increases at the expense of potential energy, it means this body is at a height h. That means it is possessing some potential energy. So let us consider this body is at a point A. So at point A, what is the kinetic energy of the body? See, we know kinetic energy is half mv square. At this point, velocity of the body is 0. Therefore, kinetic energy is 0. Then, potential energy of the body at point A. This is equal to mgh because it is at height h from the ground. Potential energy is mgh. Therefore, total mechanical energy is equal to the sum of the potential energy and kinetic energy, that is mgh plus 0. Therefore, total mechanical energy is mgh. Now, this body falls freely at a height x from initial point with velocity v. Suppose this position we are considering B. So, at point B, what is the kinetic energy? That is half mv square. And for B, use third equation of motion. That is b square minus u square is equal to 2as. Here acceleration is the acceleration due to gravity, s be the displacement. So b be the velocity of the freely falling body, b square, u be the initial velocity, that is 0. That is equal to 2gs, x be the displacement. So, v square is 2gx. So, kinetic energy will be half mv square, that is 1 by 2m, v square is 2gx. 2 cancel out, kinetic energy is mgx. Now see the potential energy. As we know, potential energy is mgh. Let us consider this body finally reaches to ground at point C. And this body is at a minus x from the ground. Therefore, potential energy is mgh. What is h here from the ground? H minus x. So, potential energy is mgh minus mgx. Therefore, total energy is the sum of the kinetic energy and potential energy, means mgx plus potential energy mgh minus mgx. Therefore, total mechanical energy is mgh. Now, suppose this body finally reaches at point C on the ground with change of the velocity. Then we have to consider the motion from A to C. Now, at third C point, kinetic energy is, we know, half of mv square. Use third equation of motion. We have v square minus u square equal to 2gs. Here u is the initial velocity. Here initially velocity of the body was 0, that is 0. That is equal to 2g. And what is the displacement from this initial position? H. So, v square is 2gh. Therefore, kinetic energy is half mv square, that is 2gh. 2 to cancel out, kinetic energy is mgh. Then what about potential energy? Potential energy is mgh. Here on the ground height becomes 0. Therefore, potential energy is mg of 0 because h is equal to 0. Potential energy is 0. Therefore, total energy is sum of the kinetic energy and potential energy. Kinetic energy is mgh, potential energy is 0. Again, total mechanical energy is conserved, that is mgh. So clearly, as the body falls, its potential energy decreases and kinetic energy increases by an equal amount. However, its total mechanical energy remains constant at all points. Thus, total mechanical energy is conserved during the free fall of the body.
Now see the numerical related to mechanical energy.
See the numerical. Calculate the velocity of the bob of a simple pendulum at its mean position if it is able to rise to a vertical height of 10 cm. Velocity we have to calculate. Height is given 10 cm, that is 10 into 10 raised to the power minus 2 meters. And g we have to use 9.8. So this is the situation. This is a bob. And this is the mean position of the bob. Here kinetic energy works. And at the extreme position, this kinetic energy changes to potential energy. So, according to principle of conservation of energy, kinetic energy of bob at mean position is equal to potential energy of Bob at extreme position. And we know kinetic energy is half mv square and potential energy is mgh. So m cancel out, v is root of 2gh. So by putting all the values in this expression, you can find the velocity. Now put the values. V is equal to under root 2, g is 9.8 and height is 10 into 10 raised to the power minus 2. So you can solve. By solving, the velocity will be 1.4 meters per second.
That's all from my side. Thank you.